Hello, my name is Winifred Ogadima Esomonu with student ID 77249064, and today I'll be giving a presentation on a microservices web-based application which consists of 3 microservices: a student portal, a library portal, and a finance portal. This diagram shows an architectural overview and flow between these 3 applications. For the student portal, the students can register, and when they carry out registration, it also registers the student on the finance portal by calling a register endpoint on finance and a register endpoint on library to create accounts. The students can log into student portal, view search course, enroll in a course, view their enrollments, view their profile and updates, and view their eligibility to graduate. On the library portal, it has 2 actors, admin and students. For the admin, they can log in. Once they log in, they are able to add a book using the ISBN, which is actually calling an Open Library API. Entering the ISBN, it generates details about the book, and they can add that book to the database. They can view and search all books. They can view loans, view overdue, view all books on loan. And the students portal, for the students part of the library, they can log in, view and search books, borrow a book, return a book, view overdue, view their borrow history, and view current borrowed books. Now, for the library, when they return an overdue book, it calls the Create Invoice API on finance accounts. And for the finance account, the students can log in, view all of their invoices, find a particular invoice, and pay that invoice. Now, likewise on the students portal, when the student makes a new enrollment, it calls the Create Invoice on the finance portal to generate a new invoice. And when the student views their eligibility to graduate, it calls the Get Account to find if the outstanding property is true or false, and then tells the students if they are eligible to graduate or not. With regards to the technology stack used, for the library and finance portals, they were built using similar technology stack, which is the parent stack. It stands for Postgres, Express, React, and Node.js. The reason for my choice in these technologies are because Postgres, starting with Postgres, it is a relational database management system, which means it organizes data into tables and uses a structured query language to access the database. It is also one of the most compliant, stable, mature databases available today. It is free and open source, and it is very good with complex queries. Some of its benefits include high performance, and its scalability features. With Express is a back-end Node.js web application framework for building RESTful APIs. It is lightweight and it provides the fundamental web application features. It has various middlewares that can be used to perform other tasks on requests and response. Also, the front-end technology is React.js. With React, it's a JavaScript library built and maintained by Facebook. It is used for building simple, fast, scalable front-end web apps. It has great performance because it offers virtual DOM program, which is a concept where a virtual representation of the UI is kept in memory and synced with the real DOM. It is easy to use, and because of its popularity, it has a huge community and support, as well as various packages it integrates really well with, and it has the features to reuse most of the components being created. Lastly, Node.js is a back-end JavaScript runtime environment. It is used in creating server-side web applications. It is easily scalable. It offers great performance and speed. It is powered by V8 engine in Google Chrome. which is written in C++, so it rapidly converts JavaScript to machine code. And then moving on to the students portal, the technology stack is Python, Fast API, React, and Postgres. I chose Python because Python is a high-level general-purpose programming language which is simple to use and to understand. It is also very versatile. It has a huge number of libraries and inbuilt functions, and it has large community support. For Fast API, it is a modern, fast, high-performance web framework for building APIs with Python and 3.7 and above. Some of its key features are its high performance. It is fast to code. It utilizes open standards for APIs and JSON schema, and it is easy to use. And according to Tech Empower score charts for the performance of several web application full stack frameworks and micro frameworks, Fast API is ranked number 6. Some other technologies I used is Docker. Docker was essentially designed to help build and run applications. So for the students portal, it was configured using Docker. It starts and runs our application. It builds our database and can actually sets up pgadmin so it can be accessed in the browser. I would also like to highlight that this application implemented authorization using JWT, which stands for JSON Web Tokens. It's just a way of representing claims between two parties. It provides secure authorization and exchanging information more securely. I also used proper password hashing and sorting techniques in creating the account to sort and hash the passwords in the database before it is being stored. Now this brings us to the conclusion of our introduction, and we move to the demo. Join me as I take you along on the demo of these microservices. We will be starting with our students portal. Here, a student can register with the following credentials. Now the account has been created, and it has also been created on the finance and the library portals, and using those details the students can log in to their account and view the student portal. On successful login, they have access to view all the courses available in the database. They can also search for a course, and it returns the record for that course. They can also enroll for a course, and if they have previously enrolled, it doesn't allow them enroll, so the enrolled get disabled and it changes to enrolled. But if they haven't enrolled for the course, it allows them enroll for the course, and a reference is generated for them to pay on the finance portal. After enrollment, they can view all of their enrollments. They can also view their eligibility to graduate, and because they now owe an invoice, which they haven't paid, they are not eligible to graduate. They can also view their profile. They can edit their profile. And successful. Finally, they can log out. Now to the library portal, starting with the admin. The admin has access to view all books. They can also search for a book. The admin can add a new book, assuming they want to add the ISBN that already exists in a database. The system does proper validation to make sure that they are not making duplicate records, and warns the user. So the ISBN is a unique field here in this case. Now, assuming this ISBN doesn't exist, which is an ISBN gotten from the Open Library API, they enter and it returns details about the books. They enter the copies they need in the system and the maximum amount of days allowed to be borrowed. And then the book gets added to the book table. Now they can check all students currently on loan and the number of books the students have borrowed. They can check all borrowed books, and they can also view all overdues and the amount of days the books have been overdue. And next, we log in as a student on the library portal. Upon login, the student is able to also view all books and search a book. Using the ISBN, they can borrow a book. They can also view all their currently borrowed books. They can view their overdue books and details about the overdue books, such as the fine, the days overdue, when they borrowed it, and the maximum days. They can view history of their borrowed books. So this returns the history of the books that have been returned in the system, just for them to see a history of what they have borrowed in the past. Back to the currently borrowed books, the students can also return the books from here, and it's successfully returned. Now, if it's an overdue book, it gets returned, but it generates a reference which they have to log into the invoice, into the finance account to pay. And now we move to the finance portal. For the finance portal, we log in with our credentials. Upon successful login, we can find invoice or get all invoices, and these are all the invoices for this user, including paid and unpaid. Now, if the user copies an invoice, a reference, and pastes it, they can actually find details about that invoice, and paid is no, and then they would pay, and pay become yes, and the paid button gets taken off because we don't want the user to pay twice, although all of the logic for that has been implemented to prevent a user from paying twice from the back end also. Now, when they get all invoices, paid becomes yes for that invoice, and then there's this final invoice which is still left unpaid, and now they can actually find invoice and pay invoice. Now, when we go back to our student portal, we can actually view our eligibility to graduate, and having paid all invoices, it should say eligible to graduate. Now, when we go into our eligibility to graduate, it calls the API from finance account to get accounts, checking the outstanding status, and they are eligible to graduate. Now, this brings us to the end of our demo, and having fulfilled all of these criteria from introduction, down to the demo, and having identified everything being specified, we will be moving on to our microservices. Now for the microservices, looking back at this UML diagram, we can see that each of these three services are microservices on their own with their separate features, and they integrate with each other using the APIs exposed from finance and library portals. There are certain advantages of using this microservice architecture as opposed to using a monolith architecture, because if something breaks on one application, others could still function. Microservices are built to scale since the modules are decoupled from each other. They are easier to deploy and they are easier to maintain. Monolith application has to be scaled even if there's really no need for every feature to be scaled. There's the issue of code complexity, limited scalability, and one of the advantages though is that it's easier to test. So the advice is, if your app is simple and you can quickly launch it, you use a monolith, else use a microservices based architecture. And now we are moving to our dependency management. So our applications depend on certain packages and libraries to run, and for this we need to find proper ways to manage these packages and library as our application use them, including the ones that run on development environments and the ones that run on production environments. So for the student portal, which was built in Python, Fast API, React, and Postgres, the dependency management here is the virtual env. When you clone a project and you run pip install requirements.txt, it installs these packages globally, and we don't want that. So in order to better manage these packages within your application, we would run it in a virtual environment instead. And this virtual environment is where our applications will get installed, as opposed to installing them globally all through our application. And for the library and student services, we made use of the package.json. It is used to manifest, store information about application and modules and their packages, and this is where all of our dependencies actually sit in. And even our dev dependencies, those are dependencies that we do not need in production environments. And now this is a look at the actual files. So this is the requirements.txt for the students portal. These are all the things that depend on to run, and we don't want to install all of these globally within our app. We want to use them in a virtual environment. So right now we are going to be making use of the virtual environment in the venv directory. Inside this VENV is where all of these packages would get installed in, and they would be used within this application. We can actually see that the packages exist in the lib directory of the VENV and also in the bin directory. And to activate this, we say source VENV/bin/activate. And for the finance and library portals, we have our package.json, and these are all the dependencies used. Likewise, in our front-end application, which is React.js, they also use the package.json with all of the dependencies and dev dependencies within them. This way, we are able to manage dependencies better and more efficiently. Also, taking a look at our library portal for our dependencies. These are the dependencies in the package.json file. For our library portal, we have our scripts that we run. We also have our dependencies in the dependencies object of the package.json. Likewise, the client's file. We also have the package.json to manage all front-end React dependencies. A quick look at the finance portal also shows the dependencies, but as well as the tests, which is run in watch mode, and then the dependencies and dev dependencies. And dev dependencies are those dependencies that we do not need to run the application in production environment. The front end of the finance portal also shows all of the dependencies used to manage this front end application. And with this, we have fulfilled dependency management. And for dependency injection, we essentially employ this design pattern, because it's a pattern in which an object or function receives another object or function that it depends on. So essentially, this is a decoupled usage of an object from its creation, leading to loosely coupled programs. This helps also in developing testable code. It allows to write tests easily. You can mock databases with dependency injection and test your application without actually affecting or manipulating or altering your actual database, or without even having to create a test database. Now, in the actual codes, taking finance as an example here, we have specific folders like the controllers, repository folder, routes, services. Starting with the repository here, in this repository folder, using the invoice repository as an example, we have the invoice repository and the mock invoice repository. The invoice repository is the one we are using directly for our database, and the mock repository is the one we are going to be using to mock our database to run tests. Now, in the invoice repository, we create all of these functions. Likewise, in the mock repository, and we export them from them. Same thing with the accounts. We create a mock repository and actual repository. And for the services, we import these repositories in the service, and this is where we specify the environment. If it's test, it would run the mock, and if it's any other one, it would run the actual repository. And in the controller, we import our services and we use them here. This is where we actually create our logic to get. And in this services folder, in this services file, we actually, when we specify the tests and the tests, when we specify the test environments here for the mock repository and the other environments for the actual repositories, we use them in our controller, and then we import our controllers to our routes. This is where our controllers are used in our routes, and with this we have successfully handled dependency injection, thereby creating a loosely coupled program. For the service integration, this, using the finance as an example again, this service integrates a RESTful API service. When we take a look at our index.js, this is where we specify the routes for each of these controllers. You importing our routes file and then specifying the routes here. When we navigate to the actual routes, this is where we import our controllers and passing any parameters such as IDs for the routes expecting the IDs. The auth middleware is actually used for authentication in this case. It just shows that those are protected routes where the user has to be logged in to be able to access resources from these endpoints. And now, having imported the controller and used them here and specified them in here, we can now say in our controllers, when we go to our invoice controller, for example, the get all invoices, this is where we import our service and add the logic. And if it returns a response of, if it returns the invoices, it should return a response of 200, else it should return the response of 500. So this is a RESTful controller that we have used now, specifying the routes of /invoices in the routes file. And in terms of service integration, there is also commonly used services like SOAP. They both share similarities, like similarities over HTTP protocol, and they have their advantages and disadvantages. For example, SOAP is language and platform independent. It includes error handling. It is more secure. It supports both stateful and stateless operations, whereas REST is stateless. It was designed to be stateless for simplicity. It is lightweight. It is faster. It is more compatible with browsers because of its JSON data format. It is more flexible. So essentially, if you are looking for flexibility and efficiency, you should go for REST because of its superior performance and high scalability. And if you are looking for higher level of security and standardization and flexibility in protocol transferring, you should go for SOAP. It is also important to mention that with this application, I've chosen REST because of its flexibility and efficiency, scalability, which is one important part of microservices, that they should be built differently and be scalable individually. It is also important that HTTP caching is also possible on just REST, and it enables to store non-dynamic information on the client side, and this improves loading speed in general. So for this application, I have gone for the REST service integration, and those are my reasons why. So with service integration done, we will be moving over to testing. Now, for testing, I have used Jest as the framework for testing. Jest is a JavaScript testing framework built on top of Jasmine, with a focus on simplicity, and it has support for even larger web applications. It works well with Node.js, and Node.js was one of the core technologies I used in building these services. It automatically finds tests to execute in your code with any files ending in .tests.js. It allows for asynchronous testing, and it automatically mocks dependencies when running the tests. Now we are going to be taking a look at this from within the code. Now, using the finance portal as an example again, we have a test folder here containing some of our tests for the invoices. Using get all invoices as an example, this is a unit test importing the invoice service and controller, and we already stated in our invoice services to specify which environments it is and which repositories to mock. So if it's test, it mocks the invoice mock repository and vice versa. If for get all invoices, we specify what it should do. So it should get all invoices. We create a mock response of what it should look like, and we call the inbuilt functions for Jest and passing the values, and create the request and response. And based on the response, we expect 200 here, because the case is for it to return all of the invoices, and if it's an error, it should throw a 500 error message. And all of this is actually based on the logic we have specified in our controller. So in our invoice controller, we can see that if it's successful, it returns 200, else if there's an error, it returns 500 internal server error. And for these tests, we also have the package.json test script setup. We put it in watch mode so that whenever we make changes within our file, it will constantly watch for changes and run these tests as we develop our code. We also have the integration tests here. So for this test to run, we could just make a simple change and watch as the tests automatically runs and watches the test files and runs all of the tests, and we can see that all of our tests passed in 8 seconds. And taking a look at the integration test file, this just tests all of the invoice controllers together to ensure that they work together and return what they should be returning. And with this, we have fulfilled the test requirements. And for the conclusion, in conclusion, we have summarized this product into 3 microservices. Namely, we have the student service, the finance service, and the library service, and they can all perform their individual actions. The student service creating an account automatically creates an account for finance and library. Enrolling automatically calls a creates invoice API from the finance, and the library returning an overdue book would automatically call the create invoice API. And we have 2 users in the library. Admin adding a book will also call an open library API to add the book, and the students would be able to check their eligibility to graduate based on calling an API from the finance to check the property of the outstanding, if it's true or false. And this summarizes our application. Now, regarding the product's limitations, some key limitations I'd like to discuss in this product is mostly based on the features. Some of the features could be improved, like the library portal could be improved on the admin side to enable them to edit a book should in case they add some records by mistake, or to even delete a book completely. The students portal could also be improved to check for grades, not just using an unpaid invoice to check for grades and then make sure the students have passed all of their courses before graduating. We could also improve it by adding email validation, because we want to be sure that the user is registering with valid credentials, actual correct emails, and not just dummy emails or fake information. And currently there's no interface for adding the courses, so that could also be an improvement to be made on these projects. The project is limited to the adding of courses is limited to Postman, and then we could also improve it by adding to the payments portal actual payments gateways. In real life situation, we would be handling payments in much more different ways, but for now this product changes the properties in the database from true to false, but we could add actual functionalities with proper payments gateways. And now this brings us to the end of the presentation, and with that I have fulfilled the requirements for discussing my product's limitations. Thank you.